Today we're going to learn about relations and functions. A relation, and make sure you guys are going to write this down, is a matching of an input with an output. So it is putting two things together, a relationship. So you can think about, a relationship with a brother and a sister, a boyfriend and a girlfriend, a mom and a dad, a mom and a son. So that is what a relation is. However, every relation also can be in math. A coordinate grid has functions or relations because a relation is an ordered pair. Now, a function is when a relation pairs one input with exactly one output. So this definition here is actually for a function. So a function is a relation, but it's when it pairs exactly one output with the input. So what we're going to do in these examples is determine whether each relation is a function. So these different relationships of points are going to help us figure out if we have a function or not. So again, a function, each input has one output exactly. So let's go ahead and write an input-output table and kind of put these into that table. Now, if things are repeated, let us not write them again, but let's just write the numbers as they come. So inputs are the x values. So we have -2, -1, 0, 1, and 2. Those are all the inputs that we have, our x values. The outputs of all these coordinates, I have 2. So -2 goes to +2. I have a -1 goes to +2. I have a 0 that goes to +2. And then I have a 1 that goes to 0, and a 2 that goes to 0. I'm just grabbing them from these coordinates. Now, let's look at what we drew. This is called a mapping diagram with our arrows. Do we have exactly one output for each input? Each input has only one line drawn out towards the output. So, because of that, yes, this does represent a function. It is okay if an output has 3 different inputs pointing to it, as long as each input has just one output. Let's try the next one. Again, we are going to write our input and our output table. So I have a -5, and it goes to a 0. So I'm going to draw an arrow. I have a 0 that goes to a 0. I have a 5 that goes to a 0. I have a 5 that goes to a 10, and a 10 that goes to a 10. Now, as I'm looking at all of these, I know I accidentally wrote this together, but 5, one input of the same number, goes to 2 different outputs. One goes to 0 and one goes to 10. Because of that, that is not a function because that input of 5 has multiple outputs. Go ahead and draw a mapping diagram or look at the tables to figure out if the following examples are, in fact, a function or not. Pause the video and then check back to see your answers. All right, so make sure your answers are checked and correct. The first table was not a function because the input of 0 had 2 outputs. One went to 5 and one went to 6. The second one, it was in fact a function. Go ahead and look at these 2 mapping diagrams and determine if they in fact are functions or not. Also, think about these true or false statements about relations and functions. Go ahead and jot down an answer and see what your answers are, but make sure you pause the video first. All right, so here are the answers for all the problems. The first mapping diagram was a function. Each input had one output. However, the second one, that one input had 3 separate outputs. Now, with the true and false statements, every relation is a function. That is false because all of the past examples were relations, and some of them were not functions. However, when you flip the words around, every function is a relation because that's where it stems from. A visual way to determine if something is a function or not is to do the vertical line test. When you have a graph, the way to determine if something is a function or not is when no vertical line passes through more than 1 point on the graph. So you could see from your examples, in the first example, there's only 1 point throughout the entire way, but not a function, it passes through the vertical line twice. So you have to kind of use your pen or pencil to see with each graph if it passes the vertical line test or not. If it does, it's a function. If it doesn't, it is not. So I've gone ahead and made my own vertical line that I can move around and see if it passes, the graph passes the vertical line test or not. If it does, we'll see if it's a function. So I go ahead and I'm going to move it across the points, and I notice right here, I just went through 2 points at one time. There's 2 points here, and I know when I move further, right here, I do it again. Now because that happens, I do not have a function here. There's no function. Now, when I do it again on this side, as I'm going through this graph, the vertical line only matches one time each, which is great. That's what we want. So because that happens, yes, it is a function. Go ahead and try it on the following 3 problems to see if those are functions or not. And then on the bottom it says, do all linear equations represent functions? So think about that and explain your reasoning. Go ahead and pause and see how you do compared to my answers when you unpause. All right, so here are the answers that I have. The circle is a no, and then the next 2 graphs are yes. They completely pass the vertical line test. Now, when we're talking about linear equations, do they represent functions? The answer is most of them do. Most of them are functions. However, the vertical lines that we've graphed in the past are not functions because they don't pass that vertical line test.